Hello, lazy perfectionist. You touch on two of my favorite little oddities in science. I've thought about these before. I'm going to claim to know the official answers, but I don't think we anybody really knows the philosophical implications. Though I have my own opinion on that as well. Okay, first of all, an interesting thing in relative motion, you use the Earth and the Moon as an example. Turns out that's not a good example. Rotational motion is not relative because those are not inertial frames. When you have something going in a circle or spinning, um, where parts of it are traveling in a circle, that's an accelerated frame, right? And that's not relativistic. You can tell when you're in a frame that is changing velocity. So things that are spinning are doing that. So, and you can think about this like it doesn't matter how fast you're going in space, there'll be no stress on you. But obviously, a thing that's spinning really fast will fly apart. So there isn't relativity, and I'm a relativist, so I like to find how thoroughly deep relativity is. It's very interesting that spinning objects are not actually in a relativistic frame because they're changing velocity. So we're all in these curved paths, so that's interesting. Okay, now on the relativistic thing where both people see the other clock as slowing down, that is, in fact, what the theory says, what tests would show. And so why in the twin paradox, where one of the twins goes away from Earth and comes back, is it the twin on Earth that grows older? And so they both saw each other with slow time frames, but one of them, when they meet, really is, younger and one's older. And the answer is because the twin that left Earth had to turn around. All that acceleration to match the frame in general relativity, in the math in general relativity, that's where that happens. That's why the one on Earth, so to speak, turns out to be right. It's because they matched frames. If they never match frames, if they go away forever, they both can correctly say that the other frame is going slower. And it's just like velocity relativity. I mean, if we're moving away from each other in space, I can say that you're moving faster than me because I'm staying still, and you could say I'm moving faster, and those are both valid. And what I think the philosophical impact is that it has to do with like this cone of relativity. If you've ever read about that, the idea in relativity is if something is beyond being able to interact with you, or even in a sense just doesn't, there seems to be an implication that it doesn't exist in a sense. Now there's another sense in which you say, well, of course it exists. It had existed. We knew it exists. Yeah, but the fact that you're not going to interact with it, it starts to make the facts go incoherent, and you can't really say, you can say that their clock is going slower, but they can say that about you as well, and that's just like I can say you're in motion and I'm at rest, and you can say the same thing. So there's one of the places where relativity goes more and more deeply. But the short answer is in physics, yeah, the clocks are both going slow for each other. It becomes a kind of a relativistic version of the whole quantum split universe thing. Alternate relativistic truths based on your frame of reference. And the interesting thing and how physics seems to work is that, if one of those bodies slows down and catches up with the other, then all the math works out, and once they get in the same point in time and start interacting, all of those questions of which went slower do get resolved. So it's the interactions and the relationship. When you have a active relationship, then those things get resolved. If your own relationship is speeding by each other at near light speed, then you don't have that high level of correlation. There's just a very small level of correlation through the fact that your frames have shared photons, and even that'll be weird because the photons coming off of your ship, if you're traveling towards me, will be bluer when I see them than they would seem to you, and vice versa. So there's all these distortions, and if you match your frames of reference and in a common interactional frame, then those distortions resolve into highly accurate, definite facts. Cheers.